Today I'm going to be talking about the NibbleTorrent peer. Before we do that, though, I just wanted to draw your attention to the schedule. So this is what I'm doing right now. I just want to remind you that there is a craftsmanship meeting starting on Friday and going till Monday, December 2nd. It's kind of mislabeled. I really want you guys to help each other with the NibbleTorrent peer. But maybe you have some suggestions for the simple TLS one as well. Uh, so please meet with your group before then. So starts on Friday. We can meet with them before then if you want. Yeah, if you want to. But Friday to Monday, you have. But that's there's Thanksgiving in between that. So make sure you do that. I really want it to be a chance for you guys to help each other with the NibbleTorrent peer, give some advice on how you did it or how you're doing or what you're struggling with, because it's a hard lab. So let's jump to that. Here it is. Hard, maybe not the hardest. Version 2 might be, of the TCP client might be a little harder. But here there's a lot of pieces to it. So that's what makes it challenging. So nothing itself is particularly that bad. It's just all the kind of things you have to do to make it work. I really like this lab. I designed it very specifically to kind of combine all of these features, all these things that you've done, a server, a client, lots of different things all together, and add some threading there as well. So it's a really cool lab. I think by the end of it, you'll feel really proud of yourself that you completed it and you've done all these things and you've made a really cool system. It's not quite BitTorrent. That's why I'm calling it NibbleTorrent. It has some simplifications to it. Things as I started to build my own BitTorrent client said, we don't need to do that. It's a little too pedantic. And so we made some simplifications, but the heart of it's exactly the same as BitTorrent is. And there are some carryover of how BitTorrent does things that I thought would be good for you to do. Kind of the flow of data, and I'll get more into this specifically, but kind of a high level overview is I'm going to give you torrent files. In fact, they're right here. You can download them. They're zip. I think there's like 3 torrent files. A torrent file is essentially like a promise. Say, hey, if you give this to a give this to a BitTorrent client, I will download that file for you. So you don't know what the file is per se, or you don't know the bytes of the file, but it's like the metadata about how to get that file. So you'll download it. Then what you'll do is you'll make a request to the tracker. The tracker will give you a list of all the peers that have that file or that are in the process of uploading that file. I'm providing the tracker for you, that server component, so you don't have to worry about that. And what you'll do is you'll get that list of the clients from the tracker, and you'll go through each client or peer and say, hey, do you have this piece? And then you'll ask them all if they have the piece. Hopefully someone has that piece, and you'll download it. And then you'll ask for the next piece. And as you're downloading it, you'll also be uploading. Peers might be asking you for those pieces. And so that's what you'll be doing. You'll keep downloading until you've downloaded the whole file. And then at that point, you'll keep on uploading until you close out your program. Like I said earlier, this is a hard lab. It involves a TCP server, a TCP client, HTTP client, all running concurrently. And you have to do synchronization between all these different threads. So there's a lot to do on this lab. Okay, so first thing, the protocol, like I said, I'm giving you these torrent files. All they are is just JSON files that have the metadata you need to download this file. So let's go through this. The first one is the tracker URL. So this is a field or a key in this JSON. There's a tracker URL. This is the URL you're going to go to contact the tracker. So here's an example of a URL to go to. So you'll be writing a HTTP client to say, hey, go get this file. And it'll get it for you. And that's how you register yourself with the tracker to say, hey, I'm a peer that's part of this swarm, but also to get the list of all the peers that are also on that swarm. Okay, so that's the first one, the URL. You'll do a HTTP GET request for that. The file size, shown right here. That's the total file. So that's one check you want to do, or just to make sure you got all the data, or just it's helpful, for reasons to tell you how many pieces you have and stuff like that. So it's just the size of the file that this torrent file represents. Next is torrents break files up into chunks. They're more manageable. Then you can talk to more peers. So it's broken up into chunks. So what is the size of each chunk? In this case, for this specific file, it's 4096. It could be anything in this lab. It'll be 4096 for all of them, but you should read it in and not just hard code that. So that's right there. Tells you how many, the size of the piece. So this piece size divided by the file size, taking the ceiling of that, should represent how many pieces you have in the torrent. Okay, next is the pieces array. That's it right here. Notice there's this dot dot. That means I don't put all the pieces on here. There's some extra pieces that aren't displayed. What this is, it's an array of all the pieces. So it should, be a 1-to-1 ratio. This is piece 1, this is piece 2, piece 3, this is the last piece right here. And what these numbers mean, it's the SHA-1 hash of the file, of that piece. So what I mean by that is, remember what a hash is. A hash is a one-way function that takes an arbitrary amount of input and condenses it down to a fixed size output. So what we've done, why would we want to do this, I guess, is a question. And this is to help with security, because I'm asking the clients for pieces like, hey, you client, I've never met you before, but will you give me this piece number 1? How do I verify that they're actually giving me piece number 1 or not just giving me some malware or something else? So this is how you verify, is you get the piece, you hash it yourself, and you check with what the tracker gave you for piece 1 of what it said. And if those match, then you know that that piece is good. Unless someone has also infiltrated the tracker, then that's a bigger problem. If it doesn't match, then something went wrong. Either you didn't download the right data, or the peers try and trick you, and then you would discard that data. So that's what these pieces are. It's the hash of each piece. And each one's different because it's each piece of data is different. Okay. The last thing is the torrent ID, which is also a hash of the whole file. So that's another way to verify that you got the whole file. Once you've got each individual piece, just to double make sure that nothing went wrong or that you didn't combine it wrong somehow, you would then do the hash of the ID or hash of the file to get and make sure it matches the ID. Okay, so that's what these torrent files are going to look like. Like I said, I think there's 3 of them for 3 different files that you're going to be downloading. They're also located right here. Okay, so your first job will be to download this file, read it in using Python. You're welcome to use the JSON library. That's part of the standard library, so don't parse this yourself. Do json.load, or loads or whatever, and load this in, and it'll convert it to a dictionary for you. So that's the first thing you're going to want to do. Then after that, you're going to say, hey, what's the tracker URL? Right there. Go and you're going to send a request to the tracker, say, hey, I'm here. But you have to identify yourself. So you're going to identify yourself in your GET request using query strings. Query strings, if you're not familiar, is kind of the way where you put extra stuff in the address bar, a way to request data, but have some parameters in there. So it has a question mark, and then a key equals, and then a value, and then separating key values, you have the ampersand. So what you're going to do is send a GET request to the tracker URL, and you're going to have 4 keys in this query string. You're going to have the peer ID. It's going to be your ID. It's unique to you. How we're going to format it is this -ECEN 426- and then your net ID. This is straight out of how BitTorrent does it. I don't know why with dashes, and this is just the way, the style of how peer IDs are often look. So if this was your net ID, then this is what your peer ID would look like. You don't want to reuse that. You don't want to have duplicate of someone else. That would confuse the tracker and not be good. Next thing you need to provide is the IP address of which you're connecting to. This will only work on BYU campus, or it should only work on BYU campus. So what you're going to do is provide only your BYU campus IP address, your private IP address. So don't provide your external IP address. That's the IP address you're providing. and then the port number in which you want to receive connections on. So this is where you're going to be hosting your server. You're going to host a server to wait for incoming connections, and this is the port in which you're going to be waiting for incoming connections to be on, both IP and the port. And then finally, you provide what torrent ID are you interested in. You're telling the tracker, hey, I'm interested in this torrent ID, because a tracker might track lots of torrents. It might only track one, but it could track more, and so you need to provide what torrent you want to track. So this is what your HTTP GET request would look like. Here's the URL, the tracker URL right there. I guess it's more than that, right there. And then you have your query string, your peer ID, and then your IP address right there, and then your port number, and then your torrent ID. All four of them are there. If not all four are there, the tracker will say, I don't know, return an error message saying, this isn't correct. But assuming you put everything in the right spot, you have it all there, then it should respond back with a JSON payload with two keys. The first key is the interval. How often are you supposed to send that GET request to the tracker again to make sure you stay on the list? Because the tracker is keeping track of all the peers, but if it doesn't hear from a peer for a while, it'll say, okay, I guess this peer's gone, and it'll remove it from the list. So it's your job to make sure you query or send your request to the tracker every 30 seconds in this case. It might be a different number, so you want to pay attention to that. But every 30 seconds, you'll send a request. Don't worry if you're 31 seconds, it's fine. My tracker handles that. But around every 30 seconds, you should send a GET request with the same parameters, just to say, hey, I'm still here. And that also allows you then to get an updated list of peers, because that's the second item in this JSON payload, is what are all the peers that are available. You will be on this list, so just to be clear, you're one of the peers, so it will send you, so you'll want to remove that, because I don't want to talk to myself, that's useless. So you're one of the items on the list, so remove it. But then it'll be all the other peers. So in this case, there's only one other peer on this list, right there. So now I know what their IP address is, I know what port number they are, and I know their client ID. So as more people join, this list will get longer and longer, but then if they stop communicating after 30 seconds, they'll get removed. Okay, before I forget, sending this GET request, you never actually built an HTTP client. You built a server, but you didn't build the client. So for this, I'm allowing you to use a third-party library called requests. Do I have that somewhere? Requests. Where are you? Did I miss it? Oh. Okay, yeah, sorry, right here. It took me a second. This is the only time you're allowed to use a third-party library. Everything else can only be standard library. But this one, you can use requests. It's a great library for sending GET requests. It's pretty much the only one you should ever have to use. It's requests HTTP for humans because it makes it super easy. Here is how to make your GET request. You'll want to read up on how to do this query string. It actually makes it really easy. So I would not do the query string by hand. I would just look up the documentation how to do it, and I think you pass it in as a dictionary to data, the data parameter or something like that, or form. So you are allowed to use this library to do your HTTP GET requests for talking to the tracker. So once again, you do not have to write your own HTTP client. Okay. So now you've talked to the tracker, you registered yourself. So now you're letting all the other people in the swarm know that you're available, and you've also got a list of all the peers that are on this swarm, including yourself. So now you're going to want to go through each of these peers and try to connect to them. So the process for that is you're going to set up a TCP connection using the IP address and the port number. You're going to send a NibbleTorrent request, say, hey, are you there? Because maybe they're gone. Maybe there's a mistake and they're not supposed to be there. So you're going to say, hey, are you there? And do you have the file I'm looking for? And then if the peer responds back with yes, then you say, hey, can I have piece X? And it'll send you the piece. You need to be able to handle up to 5 concurrent connections with different peers. So I know with this one, there's only one, so you'd only hook up to one peer. But if there's 20 on here, you need to be able to talk to 5 at once. You don't want to talk to all 20 at once. That could be overkill, because what if there was 1,000 or 2,000, then you don't want to talk to 2,000. So you have to put a limit on it somewhere. So here we're going to have a limit of 5. So you need to be able to talk to 5 different peers at once. That will take some testing to get that to verify. You might have to work with some of your peers to make sure you're all on at once, so that there's more than 5 to verify it with. How you choose those 5 is up to you. I think you should choose it randomly, but you can choose it some other way. So if I have a list of 20, I would just choose the random 5 peers and try to connect to them. If for some reason one of them fails, you keep on getting errors, then choose a different one. Randomly choose a new one. You do not have to have multiple connections to the same peer. You only need to have one connection to one peer. So like, let's say, you don't have to have 5 concurrent connections to this one person right there. This is meant for 5 different peers, but they have to be concurrent. So if you're doing this with threads, which is what I suggest, then that means you're going to have at least 5 threads going on at all times to talk to those peers. Okay, so what does this whole request look like? So creating a TCP socket and connecting, you know how to do that. You've done it lots of times. But how do I send a NibbleTorrent request? And how do I request a piece? All that stuff. This is what the next step is, our next part, is what does this request response format look like? And here it is. This right here. This should look pretty familiar to you. It's very similar to last lab. You have a version, a type, and a length. Based on the type, you will interpret the data based on that. So I give you all the details about the version. We're only using version 0.1, so don't worry about that. I mean, just put it in there. The type, there's a couple different types, in fact 4. A hello request, hello response, a piece request, and a piece response. And then an error. I need to update this to say 5. There's 5 different types. Error response is the last one. Length of the payload, and then based on what the type is, you're going to interpret the data differently. Very similar to the last lab. In fact, I don't give you code for this lab. I would start with kind of the formula for how you did last lab, with having the messages.py. I would copy that code and start changing it and replacing it with this type of stuff. I think how it was designed in the last lab is a really good way to kind of approach this lab, at least for parsing the messages and figuring out the types and creating the different message types. Your peers should be able to send and receive all these requests, these NibbleTorrent requests and responses. Because you'll be sending requests out to peers to say, hey, do you have this chunk? But remember, you're also an uploader. So you're also going to be receiving these requests. Say, hey, hello, can I have this request? So you're going to have to be able to handle all of these different types of messages. So what does a hello request and response look like? So it's got a type 0.1. And what you're going to do in the hello request is you're going to send the torrent ID of which you want to receive data for. So this is what it looks like in hex. I do want to remind you, it is in a binary format. So this is not actually what you're going to send. You're going to send it as binary, but I wanted to be clear, or just show you some representation of it. That also means that the BitTorrent ID, I know the ID is in hex here everywhere, it's hex there, but you're going to be sending this as binary. Okay, so we got the 0.1, that's for the version right here. We got the type, that's another 0.1. And then we have, what's the length? It's 0014. And then the rest of it is the actual data. In this case, for a hello request, you send the torrent ID. So you're saying, hello, do you have this torrent? Are you part of the swarm? And it will respond with the 0.2 and a list of all the pieces it has for that file. And how it sends this is in a bit field. It's an interesting format. It's a really condensed format. What it does is it flips a bit for every piece it has. So the first bit says, do I have bit of piece 1? If I do, then I make that first bit a 1. If I don't, I make it a 0. So for example, if I had piece 1 and 3, this is how I would set the bits. If I only had the last piece, then I would set it this way. So hopefully it makes sense. It's called a bit field. And so it's a way to condense a lot of information together because it's just a bunch of little flags you're going to treat it as. So this torrent right here, this is a real torrent. It has 42 pieces. If you had all 42 pieces, then this is what your bit field would look like. There's 42 ones here. I have every single piece. But 42 is not perfectly divisible by 8. And we have to deal with bytes. That's on a socket, we can only send bytes of data. We can't send bits of data. It has to be divisible by 8. And so you need to add some padding to make it divisible by 8. The receiver will know because it knows how many pieces are part of this torrent, because that's given right here how many pieces there are in this array, or by dividing these two. So it should know. So it'll know what's padding and what's not padding. You'll figure that out. So you don't have to worry about that, but you need to add it in order to send the data. Once again, you're going to be doing both. You're going to be sending these requests when you want a piece, but you're going to also have to send this response if someone asks you for a piece, because you're both an uploader and a downloader. Okay? So let's assume we're trying download. So we send this request, we get this response back. If they have all the pieces, great. What you need to do is compare what they have to what you have. And you want to find everything that they have that you don't have. And then from there, you choose a piece to ask that peer for. How you choose that piece, it's up to you. You could go from left to right. I randomly chose it. I think that's the right way of doing it, or the best way, but you can do it however you want. You just need to pick a piece that they have that you don't have. Of course, because if you have the piece, then why are you asking for it? And if they don't have the piece, then why are you asking for it? So it has to be the combination of they have it, but you don't. Okay. So then you're going to move on to the piece request and response. So you're going to say, hey peer, with your same TCP connection, you're going to say, hey, here's version 1. The message is type 3. The length is only 1. You're only going to send 1 byte of data. You say, hey, can I have piece 2? Just so happens maybe that they have piece 2 and you need it. So, hey, can I have piece 2? And what it'll do, if this all worked properly, is it'll send a response back, 04, with the piece of data. And this is the length right here. And then here's the data, the binary data. So you'll take in that binary data and you'll put it somewhere. We'll talk about that in a second. If something goes wrong for some reason, then you need to respond back with a type 5 message, an error response, and then an ASCII message describing what went wrong. So in this case, this is an ASCII for piece index out of range. Oops, I didn't mean to click. Okay. So that's what you need to do if there's an error. So hopefully that dance of requesting and responding will make sense. You have to be able to handle both sides. Here's the CLI for it. Nothing particularly crazy. You have to provide your net ID, because that's what you're going to be putting into your peer ID. And then you also have to say what torrent file are you going to download and seed. Just a helpful way to debug this. You can add extra flags if you want. These are just the required flags and the flags that you need to demonstrate. But like when I was building this, I added a couple other flags like download only or upload only, because I was just like trying to isolate, like, hey, I just want to work on the uploader. I just want to work on the downloader. I don't need all these things. So so you can add extra flags to change the behavior of the program for debugging and testing purposes. But when you just provide the default flags, it should work. It should do both those things. But that could be helpful to use. Maybe you want to add some extra flags. Okay, so what's the flow of the program? You have 3 essentially big jobs to do. You need to be constantly handling, calling the tracker. You need to be downloading data, so you need to be reaching out to peers and connecting to them, and hopefully no errors occur. Or what if you get to the point where you have all the pieces that peer has? Then you probably should disconnect from that peer and try to find a new peer. So you're constantly looking for new peers, sending requests. Remember, you have to have 5 of these. And then you also have to be uploading. So you also have to have a server running behind the scenes that's waiting for requests to come in. All doing this in parallel. And spawning new threads. Okay. Uh, so this is what the diagram helps me, I don't know, hopefully it helps you, is your peer.py is going to be doing three major tasks. That's what the colors are for. So we run the tracker. The tracker is going to contact, your tracker thread, let's say, it's going to be contacting the tracker every interval and repeating this over and over again. It might be during this time of contacting the tracker, you're going to get a new list of peers every time you contact it. It might be new, might not be. So you need some way of sending that information of the peer list from the tracker to the downloader, because the downloader needs to have a fresh list of the peers at all time. I leave that up to you to figure out. You could use a queue. You could use a global variable. I don't suggest you do that, but that's something you could do. It's up to you to figure out how to actually share that information with the downloader. The downloader is going to take this information, this peer list, and to figure out which peers do I want to select. Excuse me. Which peers do I want to download data from? It's going to pick up to 5 peers, and then it's going to send a piece request. Well, first, it should send a hello request, hello response. And once it's sent that, it's going to send a piece request, piece response. It's going to keep doing that over and over again until you got all the pieces from that peer. Once you got all the pieces from that peer, you can drop it and pick a new peer. So you're going to be doing that all in parallel. So you're going to have a thread for the tracker. You're going to have a thread for probably this downloader that's also selecting peers, and it will spawn up to 5 other threads for each one peer. So we're up to 1, 2, then 5. So 7. 7 threads so far. But as you download these pieces, you need to let the uploader know that you now have access to these pieces. Because let's say you started with nothing. So your uploader's like, I got nothing for you. So someone requesting, you're like, I got nothing. But as you download these things from peers, you want to make sure that it uploads it, that you're sharing what you downloaded with the community. So you need to notify your uploader. So your uploader is going to be a server that's running, waiting for piece requests, waiting for hello messages to come in and sending responses back. There needs to be some coordination between when you download a piece, how to notify the uploader that this piece is now available for it to advertise and serve to other peers. This is the most challenging part, I would say, or a challenging part in this lab. So give this some good thought. I give you some suggestions. Go ahead and use the file system or use memory. One thing is, this does not have to be a very efficient program. It just has to work. You can add optimizations later if you wanted to. So it's totally okay to create a file for every single piece. And all this uploader is doing is monitoring the file system. And if it sees a new piece come in, it updates its bit field and can service up that piece if someone requests it. That's totally fine if you want to use files as a way to coordinate between these things. It's not super efficient, but it is nice because it scales really well. If you had 1 million pieces, then file system can handle 1 million pieces. If you do this in memory, you aren't going to be able to hold maybe 1 million pieces in memory unless you have lots of memory. So there are trade-offs of both. I leave it up to figure out. Probably the optimal answer is to do both, a little bit of memory and a little bit in the file system. But you don't have to do that. You just need to make this work. If you're interested, you can make it fancy, but you don't have to worry about that. Just make it work. And that's it. Yeah, I'm trying to think. I think that's it. Oh, I guess in terms of testing, I recommend that you break this up into smaller chunks. Focus just on the tracker part. Get that working. Okay, cool. And then work on the downloader part, and make sure you can connect to peers and spawn threads and stuff like that. And then work on the uploader part. I know there are some, they are connected together in different ways, so it's a little hard to test, but it is worth figuring out a good game plan for how you want to test this. Sorry, one piece I forgot to mention here is at some point you're going to be done downloading pieces. You're going to have all the pieces, so that needs to trigger some logic here in your download to say, oh, okay, I'm done downloading everything. Stop all these peers. I don't have to select any more peers anymore. I'm done. You won't exit because you'll still be uploading stuff. You want to be a good citizen, right? You want to keep on. You don't want to be a freeloader, right? So you don't have to download anymore, but you still want to upload. So this program should run forever until you hit Control C. Okay. I am providing some tester bots. You'll know that they're my bots because it's ECN426-bot, and then with the with 0 or more characters at the end of it. It's like bot 1, bot 2, or bot uploader 1, downloader 2. I'll have some bots that only download, so they never fill up their buffer. I mean, what I did behind the scenes is I just download and I delete the piece. I don't actually keep the piece. So it'll always be downloading. So that's a good way for you to test your uploader. I also have pieces that are always uploading. So if you request a piece, it has the whole file and it should seed it to you. So I'll have both those things for each torrent as a way for you to test it. Take a look at these. These were helpful to me as I built this. Some of these things are hard. And now, one more thing, I guess I didn't have this in the requirements. It's free game to use any part of the standard library. In past labs, I said like only use the socket library to create a server. Now you're allowed to use anything you want. You can use a thread pool object. You can use a higher level server command. There's lots of things you can use potentially. So the whole standard library is fair game, and so is the request third-party library. Everything else, third-party, is not allowed. Okay. I think we're good. Good luck. Start early. It's not too bad of a lab, but it does take time. There's a lot to this, and a lot of things can go wrong. So please start working on this as soon as you can, so that you can, hopefully have a not too stressful end of the semester. Okay, good luck, and we'll be talking about this more throughout the lectures. I'll give you some hints, and if you have any questions, I'd be happy to answer them. See you later.